This is one of a series of revision sessions produced by the Further Mathematics Support Programme. In this session we'll be looking at the Edexcel FP1 specification and the topic of series. For this topic the specification is quite straightforward and simply says that you should be able to sum series such as sigma r equals 1 to n for r, r equals 1 to n for r squared, etc. and use these to look at more complex situations such as the one in the specification sigma r squared plus 2. Now the formula sheet that you have in the exam gives you the basic formulae for sigma r squared and sigma r cubed. So these you're given, and unless you're asked to prove them, which you may be at the start of a question, although that sort of proof will be covered in another revision session on induction. But so unless you're asked to prove them, then you can simply quote them from the formula sheet. The one that you may require, which is not here, is the one for sigma r. Now sigma r from r equals 1 to n is equal to 1/2 n plus 1. Now you're not actually given this directly, you may be able to remember it. However, if you do find yourself in any sort of problems remembering this, then if you look at the formulae which are given for C1, you are told that the sum of an arithmetic series is equal to 1/2 n and then a plus l, where a is the first term of the series and l is the last term. Now of course the sum of the integers, sigma r, is simply an arithmetic series with a equal to 1, the first term 1, and the last term n. So there we have the formula sigma r equals 1 to n of the integers r is equal to 1/2 n plus 1. So all of the relevant formulae you're given. One other thing I'd mention, and it's worth remembering, is that sigma r cubed can be written as 1/2 n plus 1 and then all squared. This is sometimes useful to remember, particularly when you're factorizing some of the expressions which arise in questions. What we're saying here, of course, is the sum of the cubes. So, for example, well, for 1 cubed plus 2 cubed, etc., plus 3 cubed, up to n cubed, is exactly the same as 1 plus 2 plus 3 up to n in a bracket and then all squared. Worth remembering, although it's unlikely to be asked directly within the context of FP1. And before we just move on to look at some questions, this type of question here, of course we can rearrange this to be sigma of r cubed plus 2 sigma r. I'm missing off the r equals 1 to n there just for clarity on the screen there. Here's a typical question from this topic. Just looking through the question in its entirety first of all, and then I look at the different parts. So we're asked to use the results this time, not asking to prove the standard results, but then to use those standard results to show that this expression sigma r plus 1, r plus 5 is equal to a long formula here, and this of course will come out with the work as we do it. Once we've done that, then we're asked to find the sum of, you'll see the left hand side here, from r equals 20 to 50. Okay, so here's the first part of the question. The first thing we need to do then is to look at the left hand side, the sigma r plus 1, r plus 5, and multiply out these brackets. I'll do that in two stages. First of all, taking the two brackets themselves so that we get r squared, and then plus r and plus 5r, so in total plus 6r, and finally plus 5. And then that then becomes equal to sigma r cubed plus 6 sigma r squared plus 5 sigma r. Now then, we can use the difference expressions that we know for r cubed, r squared and sigma r to substitute into that. So just going across the left hand side to give myself plenty of room now. Sigma r cubed, we can look it up, it's 1/4 n squared n plus 1 all squared, and then we've got 6 times sigma r squared, and sigma r squared is 1/6 n plus 1 2n plus 1, and then we've got 5 times sigma r, and sigma r is 1/2 n plus 1. So there's our expression written out. Now what we need to do is to simplify to try and get down to the expression on the right hand side up here. Now we'll see here that we've got the thing fully factorized, and that's the key to doing these. One area that we see students getting into difficulty with this sort of question is that having got to this stage, then multiplying out these expressions, and of course you get then a very unwieldy expression which is in n to the power 4. The key is to factorize as much as possible before you start multiplying out. There's a little bit of help in the actual question itself, because you can see that each of the expressions that we've got on this third line here has got part of the expression which is in the right hand side of the question. You can certainly see that we've got n and n plus 1 in each of these. Here's an n and n plus 1, n and n plus 1, and also n and n plus 1 here at the end. Now the other thing that's clear is that we need to take out the fraction 1/4. Now before I do that, I'm just going to cancel a little bit on here, so there's nothing wrong with just using the old cancelling out of the numbers there, the 6 and the 6. But other than that, I think that's all we can do. So I'm now going to take out that factor from this expression, the fraction 1/4, n and n plus 1. And then to see what's left from each of the expressions that we've got on the line above. You see the first term then, if n and n plus 1 has come out from here, we then are left with n and n plus 1. In the second term, we have the 2n plus 1, but remember we've taken out a fraction of 1/4, so in fact we then get there 4 times 2n plus 1. And the n and the n plus 1 from the final term have gone, but for a similar reason we've taken that fraction of 1/4. Well, 1/2 is 2/4, so we've got 5 multiplied by 2, so the final term there is 10. Well, there's nothing really we can do to factorize this expression in the square bracket. So let's multiply it out, see what we get. N squared. you don't need to multiply out each term. You can actually do this part in your head. So we've got n squared, then how many n we've got? We've got n here, and then plus 8n, so in total 9n. And then the number term, well, we've got 10 at the end, but also here 4, so in total 14. Now that does factorize, and of course we can see it factorize. Well, hope it factorizes because of the question again at the top. That's 1/4 n, n plus 1, and then n plus 2, n plus 7. Do check that that final factorization of the square bracket here does in fact work, just to make sure that you haven't made any errors in the lines above. But once you've done that, that's the end of the first part of that question. Well, this is a 5-part mark, a 5-mark part to this question, and just to show you where those marks are allocated, the first method mark comes in this third line down of my writing, and that's where you use the formulae for sigma r cubed, r squared, and r. So you've got a method mark at this point, m1, and if you get the line fully correct, also then an answer mark. So this is m1a1 in this third line here. The next method mark comes for the factorization of n and n plus 1. So m1 at this stage, regardless of what else you get. So as long as you factorize out the n and the n plus 1, there's a method mark then. And then the accuracy marks at the end are firstly for this line where you've grouped together the things in the square bracket, and if that is completely correct, A1, and finally for the final factorization. So there's the 5 marks allocated to that part of the question. Right, now turning our attention to the second part of the question, which says use your result. Hence, notice there's hence there. You won't get any marks at all for using any other method here. So hence, you need to find the sum from r equals 20 up to 50 of r plus 1, r plus 5. Now this is a standard sort of technique. It's similar to the idea of integration. If you think about this as going from 1 up to 50, our summation, we actually want to go from 20 up to 50, so we need to take away everything below that, in other words from 1 up to 19. So if I call the expression that we have at the top Sn, then the sum that we want, sigma r equal to 20 to 50 of r plus 1, r plus 5, is then equal to S50, in other words substituting the value of 50, minus S19. Now, once you've decided that, it is literally just a substitution of the value of 50 and 19 into the expression that you have in the question. Notice that you could do the second part of this without having done the first part. So you're given the expression to use. So if you find that you get into problems, please make sure that you do the second part of the question. And of course now we're substituting, so we get 1/4 multiplied by 50 multiplied by 51 multiplied by 52 and multiplied by 57. So that's the first, that's S50, and we're subtracting that from that 1/4 multiplied by 19 multiplied by 20, 21 and 26. That's just then calculator work. The actual answer comes out to be 1,837,680. Right, well, where are the marks allocated in this case? There are only 2 marks. The first of them comes from this method mark here. Sorry, I beg your pardon, M1, for using the idea that it's S50 minus S19, and then an accuracy mark for getting the value at the end. So just those 2 simple marks. Okay, moving on to another question then, similar in its nature in that we have to use the results for sigma r and r squared this time, so just 2 of them, to show this expression here is equal to a given algebraic expression in the question. And again, using that result, so we've got the hence, using the result, this time slightly more complex in that it's algebraic, but the technique is going to be the same. We're going from n plus 1 up to 3n, so we can use that idea of subtracting. And you'll notice that more marks allocated here simply because it's slightly more complex in it being algebraic rather than numerical as it was in the first question. So the first part of the question is asking us to use our results for sigma r squared and sigma r to show this is true. Well, again, the technique, of course, is to take the left-hand side, sigma 2r minus 1 all squared, and see what we get when we're multiplying that out. So of course, that is sigma of 4r squared minus 4r plus 1. Which we can then express as 4 sigma r squared minus 4 sigma r plus, I'm going to write it as sigma of 1. This is from r equals 1 to n. Now the reason I do that is because this is a common area of errors in exams. This gets left as 1, and of course you'll appreciate that it's not 1, it's 1 plus 1 plus 1 n times, so this becomes n on the next line. So that the substitution then of our formula, which again we can quote, it's 4 multiplied by 1/6 n plus 1 2n plus 1 minus 4 times 1/2 n plus 1, and then that crucial little bit at the end is plus n. This time a little bit of cancelling if you wish. We've got 2 will cancel here to give us 2/3 rather than 4/6, and here to give 2, 4 times 1/2 being 2. Again, the question is helpful in that it tells us what we're looking for, so we can see that the things to factorize out of from here are the fraction 1/3 and n. So that left in the big bracket this time, from the first expression, we've got 1/3 and n, so we're left with 2 multiplied by n plus 1 and 2n plus 1. And then we've got minus we've taken n, so we've got the n plus 1, but we've taken 1/3 as a factor of 2, so 2 is 6/3, so we're left with 6 multiplied by n plus 1, and again finally at the end n has gone, but we've taken 1/3 as a factor, so this is now 3. Again, another common area of slight slips is this sometimes gets left as 1 rather than being 3. So remember that you've taken out this factor of a third. You can think about it just to check by doing a multiplication. 1/3 n multiplied by 3 is equal to n, and you can do that for each of the terms. Now, although this one will factorize, the square bracket will factorize, and 2n plus 1 is in here, I think most of you will probably multiply out that bracket, and that becomes 4n squared plus 6n plus 2, and then minus 6n minus 6 and plus 3. And if we now check what we've got, well, we've got minus 6n and plus 6n. So if you check then the totals, we've got 2 and 3 giving 5 and minus 6. So that's 4n squared minus 1. So 1/3 n brackets 4n squared minus 1. But of course that's not the expressions we were asked to give it. We've got to realise that the square bracket is the difference of two squares to get 1/3 n and then 2n plus 1 and 2n minus 1. Looking at the mark allocation for this, there were 6 marks. The first method mark again comes at this stage here, where you've used the formula that you can quote. There's then an accuracy mark for these terms, these first 2 terms here, A1, and a B mark. Now a B mark is one regardless of what else you've done, you simply get that for realizing that this is n here. The method mark on the next line comes for this factorization of 1/3 n, regardless of what goes on inside the square bracket, although there is then an accuracy mark for getting that correct in that square bracket. So that's 5 marks being allocated so far, so the final mark comes right at the end. As long as you've shown sufficient working to get to that point, then, and there have been no errors in the calculations from then on. So there's the 6 marks for that part of the question. The second part of the question is then again a hence question, and this time we're going from r equals n plus 1 up to 3n. So we can use the same technique as before, that the sum from r equals n plus 1 up to 3n of 2r minus 1 squared is equal to the sum from r equals 1 to 3n, 2r minus 1 all squared, minus the sum of 1 up to n of 2r minus 1 all squared. So we're going to use the values of 3n and n substituted into the expression that we proved in the first part of the question. And just to write it down for you, we'd shown that that sum from 1 to n was equal to 1/3 n, 2n plus 1, 2n minus 1. Now, in fact, it's probably going to be easier to use the line before or it may be easier rather to use the line before, which was 1/3 multiplied by n and 4n squared minus 1. I leave you to decide which way you want to do. You could perhaps use that line. I'll use it by multiplying out using the expression at the final part of the question. So we're going to substitute the values 3n and then n. So here we go then. So this is equal to 1/3 multiplied by 3n, and then 2 multiplied by 3n plus 1, and then 2 multiplied by 3n minus 1. And then we're subtracting from that 1/3, and then we're substituting n, so 2n, sorry, beg your pardon, 1n, and then 2n plus 1, and 2n minus 1. Now, the factorizing out here, the 1/3 n can be factored out. Clearly 2/3 can be, but it's not so clear where the 2 is coming from just at the moment. So we'll take the 1/3 out, and in the bracket then you have yes, in the bracket here we've got this first one will be 3 times, and then we've got 6n plus 1 and 6n minus 1, and then minus 2n plus 1 and 2n minus 1. So calculating this as 1/3 n, we then look at the squaring. Well, these are difference of two squares, obviously. This is 36n squared minus 1 multiplied by 3. So let me put that in. 3 times 36n squared minus 1, and then minus, and this is 4n squared minus 1 in a bracket. And now we can simplify that expression. 1/3 n, and then we've got 3 times 36, the 108 minus 4, so 104 n squared. We've got minus 3, and then plus 1, so minus 2. Now we can see where that factor of 2 came in, so just writing it at the end there, that's equal to 2/3 n brackets 52 n squared minus 1. There we are, that's the question finished. So we found a and b, the integers. We could quote at the end that a is equal to 52 and b is equal to negative 1. So just quoting, a is equal to 52, b is equal to negative 1. Right, looking at the marking for that, 4 marks. So the first method mark came as before by realizing that how to do the question in terms of this subtraction of 2 summation formulae that we'd calculated in the first part of the question. There's an accuracy mark for this second line, a method mark, which is what's called a dependent method mark. So if you haven't got the method correct in the first part, then you won't get this one, but factorizing out that 1/3 n, and finally an accuracy mark at the end. So the 4 marks are there. Okay, so the topic of series there with 2 exam questions which are fairly typical of the Edexcel papers. If this has been of use, I hope then you could look at further revision sessions and also look at the further mathematics support program in general to help you with your studies.